Well, my name is Nicoline Soede and I come from the Netherlands. I work there at the Wageningen University since my graduation as an animal scientist. And since then I've been working on pig reproduction. My presentation will be on sow reproductive performance, different aspects and factors that influence the sow reproductive performance. I'm very happy to be here, delighted to be here actually. I've never been to Thailand, so it's great to be here and have the opportunity to, well, see how everything is going here. When we talk about sow performance in the world, there are quite some differences between the different countries. I have to see now where I can stand the best. Completely at the edge, I think. If we look, these are some results from 2011, so a few years old now. When we look at where we are in the Netherlands, Mark already said it, we are on average at about 28 piglets weaned per sow per year. And that's doing quite well compared to a lot of other countries in the world, well, except for Denmark, our big competitor, you could say, that perform even better. You can see that back in number of live born, of course, which is quite high, but also farrowing rates are quite high. So there we achieve these high piglet numbers. Okay. Even within a country, there are, of course, big differences between different farms. And you can see that also here, for the Netherlands, for example, if you look at the top 20% of all the farms compared to the average, you can see quite some improvement actually in all the sow characteristics. So even within a country as the Netherlands, there is a big difference between all the farms. And I'm sure that must be the same here in Thailand or in the Philippines or whatever we're talking about here, that there's big major differences between farms. And that actually means that there is improvement possible on all those farms, even in difficult conditions as you may be in. And it's not the end of it. We are still improving. What you see here is the number of piglets born alive and weaned per year for, well, a large part of the 2000s. And you can see that that number is increasing, well, actually quite rapidly all the time still. So when we talk about the number of piglets weaned per litter, we went from 10 in 2000 to more than, well, almost 12 in 2010. And it's still increasing all the time because of genetics. So we have to live with the fact that even sow production will continue to improve for the next years. And as I said, there is quite a lot of variation in performance between farms. And that's a lot to do, I guess, with the management skills of the farmer. And they are, well, they need to be there for estrus detection, insemination, handling of the animals, avoiding stress. Nutrition, of course, is a very important part of impact on reproductive performance, and housing and climate are important, and those are far more difficult to control, but even that is possible. There are a lot of factors influencing this performance, and on this much too busy slide you see it all compromised. I put it on because I know this presentation will also end up in your information, so you can have a look at it maybe later to see all the components. And it's much too much to talk about this morning. Of course, when we talk about the influence on reproduction, a very important part is the lactation period. Because during the lactation period, already the follicles are developing for the next cycle. So that's a major influence. And I will be talking for the most part of my further lecture, I will be talking about this lactation period and how to optimize this follicle development for the next cycle. Apart from the lactation period, also the weaning to estrus interval is important, but that's only a very short period, of course, usually only 5 to 6 days. So a very short period to make any major changes. When a sow has its estrus, of course, we have to inseminate the sow, and we have to do that at the right time and the right way to have a good performance. So all these phases are important, and in all these phases there are different things in management that are important, And I will try to, well, hit a few of those factors. So there are some, well, major challenges, you could say, to the reproductive performance. And first of all is the reproductive performance of the second parity sow. And a large part of my talk will be on this second parity sow. If I have time, let's see, if I have time, I can also talk a little bit about the change in the genetics and the increased litter size and what kind of problems that causes. And lastly, in Europe, we have changed to group housing systems for sows during pregnancy, and that has also caused some, well, problems, you could say, some challenges to the reproduction. If I have time, I can talk about that, and maybe some other welfare-friendly housing conditions, but only if I have time. The second parity sow. What's happening with this second parity sow? Well, already quite a long time ago, Morrow et al. Found that second parity sows had a lower litter size than first parity sows. Normally, you would expect that the litter size goes up from parity 1 to 2 to 3 to 4 and then goes down again slowly. But he found that on many farms, there was a decrease in litter size in the second parity. Should not be the case. And also later, people found that these first estrus sows had a longer weaning to estrus interval and also a reduced farrowing rate. So specific problems related to the second parity. And even later, in our own group, Anne Wintjes found out that even the uniformity of the piglets, of the litter born in the next cycle, was less good, so more variation between the piglets in the cycle after the first one. So this second parity sow has a lot of reproductive problems. Some people say we don't have that problem, or a lot of people say actually we don't have that problem. But it's important if you want to find out if a farm has that problem, is that you have to analyze the results from the first estrus after weaning. Of course, if you have a bad farrowing rate from the first estrus after weaning, and the sows are inseminated again 3 weeks later, those sows will often have a better performance. So if you take those into account, you won't see that you have a reduced litter size. So to be able to pick up this reduced litter size from the first litter, you have to look at the results from the first estrus after weaning. And you might be surprised about the results. So this second parity sow is not doing very well often. And this is related to the weight loss during first lactation. And this is a graph from a paper by Taker and Bilkai in 2005 that kind of shows this relationship between the body weight loss during lactation and subsequent performance. What you see here is the lactational weight loss in percentages. So these sows lost less than 5% of their body weight, and that's the body weight between farrowing and weaning. So these sows were, I don't remember exactly, but they were either weighed immediately after farrowing. Well, normally you don't want to do that because you don't want to take the sow out of the crate. So probably they weighed the sows when they went into the farrowing crates a week before farrowing, and they kind of made some nice corrections for the litter size and the weight of the piglets, etc., to have an estimated weight at farrowing. So these sows didn't lose a lot of weight, whereas these sows lost a lot of weight. And you can see the consequences for the litter size, subsequent litter size. And what you can see is that its litter size is going down, especially when the weight loss exceeds 10%. You could say that it looks kind of stable here, and then there is a big drop. And that's actually the case for the first parity sows, the parity 2 to 5, and also sows that are much older. But as you can imagine, the first parity sows end up much more at that side of the graph. More first parity sows will be in this side than they will be here. So this is the effect on total number born, but actually they made a similar graph for the effects on weaning to estrus interval and farrowing rate. So the weight loss during lactation is an important factor for subsequent performance. The French did some research on it also, and they found out that it's not the same problem on every farm. So some farms really have a prolificacy problem, meaning that the litter size in the second parity is lower than the litter size in the first parity, the case in almost 40% of the farms. Some farms really have a problem with farrowing rate, 45% of the farms, and other problems, other sows may have specifically the weaning to estrus interval as a problem, and some farms have all the problems. They are the lucky ones. Yeah, so it can be different. The phenomenon of the second litter syndrome can be different from farm to farm, but it's seen on many farms. So where does that come from? Especially this first litter sow. All sows have to produce a lot of milk, and they need a lot of energy to produce this milk. Actually, sows produce, if they have a lot of piglets, they can produce up to 12 kilos of milk a day. So they need a lot of food to, well, to make this milk, you could say. A problem of the first litter sow is that they often have a low feed intake capacity. They simply are not mature enough to take in enough feed. And also, they have limited body reserves. They are not fat animals yet. They have just limited reserves. So they lose a lot of weight during this first lactation. And the consequence of that is that the follicles in the ovaries are compromised. They don't develop well. And that's because of the, especially when you look at the hormones behind that, because of the low LH levels, luteinizing hormone from the brain, and low IGF-1 levels in insulin-like growth factor, so an intermediate of nutrition. They compromise follicle development. Because of that, you see a low ovulation rate and a high embryo mortality, so a low embryo survival, and that's what causes all the effects that we just saw on farrowing rate and litter size and everything. To be able to understand this a bit better, I need to show you a graph that may look complicated, and I'll walk you through it a bit. What you see here is the follicle development around weaning. So this is the time of weaning. So this is lactation, and this is the period after weaning up to ovulation, estrus and ovulation. What's happening during lactation is that follicles, there are many follicles, and they are varying in size. You can see that, some variation is there. They are growing a bit on average, but not a lot. And the reason that they are not growing a lot is because during lactation, LH, this one, LH, shows this pattern. And we call this a pattern a high amplitude, low frequency pattern. And this does not make follicles grow that much. And it is so low, this pattern, because the piglets are suckling. Most important, it's the suckling of the piglets that reduces this LH levels and also the energy balance of the sow. Well, right at the moment of weaning, you see that this pattern dramatically changes. So you see an increased pulsatility with smaller pulses. And this is the trigger for subsequent development. So this makes the follicles grow. But the way they can grow is very much dictated by how they are grown during lactation. So if they are small during lactation, they will grow out, but they are worse quality and probably fewer follicles than when the development during lactation is already going on. Well, in the remainder of this period, follicles grow and grow. They start producing estrogens, estradiol for estrus behavior, important, and finally they will ovulate. Well, it's a rather complicated story, but I hope I made it a bit clear. If we look in the recent years how weight loss has affected reproduction in, I must say, probably in the modern breed, so it's research from Canada and the Netherlands mostly, I guess, then we saw that in the 1980s, and also Australia, some papers, if we look in the 1980s, if sows lost a lot of weight, what we saw was an increase in the weaning to estrus interval. Sows simply did not come in heat. They waited, kind of, till they were restored, and then they came in estrus. Later on, we saw some changes. And if we look at the sows nowadays, then we hardly see any effects anymore on weaning to estrus interval, but instead we see effects on embryo survival finally causing these effects on litter size, farrowing rate, and birth weight uniformity. So some changes related with the change in genetics. And I have an example of a recent experiment done in the Netherlands showing this, actually, where we had first parity sows that either lost, well, relatively a mild weight loss, less than 14%, and animals that had a high weight loss, more than 14%. I told you that the cut-off point between weight loss having effect or not on reproduction is somewhere at 10 to 12%. Well, in this case, we made the cut-off point at 14% because you can see we have then the same number of sows in both groups. Well, what you see is that this weight loss during lactation was 22 kilos versus 35 kilos. They lost mostly muscle. We measured the width of the loin muscle on the back, and you can see that there was a high, extra high muscle loss, whereas the back fat loss was not different between the two groups. And that's also one thing that affects it. Some genotypes may lose more protein, and other genotypes may lose more fat. And I'm not sure yet where that balance lies and what is affecting that. But in this case, it was more the protein loss. And we could see that at day 35 of pregnancy, when we slaughtered these sows, they had a 75% pregnancy rate, and these a 96% pregnancy rate. And you can also see that the animals with a high weight loss had much fewer embryos at this stage, fewer number of implantations and embryos. So the weight loss affected embryo survival in our experiment. We did not see effects on ovulation rate, so the number of eggs released, which was on average 22 in these animals. And that's what I showed you also on the graph before. So there may be differences in the way this lactation weight loss works. Sometimes it's weaning to estrus interval, sometimes it's ovulation rate, sometimes it's embryo survival, but it's always affected by the weight loss during lactation. So, and as I already said, the general recommendation is that sows should not lose more than 12 to 13% of weight. I'll do this one very briefly, because it's not the major things. It's just the background on how this is working, how the mechanism is. So actually it all starts with these compromised follicles that not only affect the quality of the follicles, but also the oocyte which is in the follicle, and this oocyte finally becomes the embryo, of course. So the follicle is important because it becomes the corpus luteum that needs to produce progesterone throughout pregnancy, but it also produces the oocyte that becomes the embryo. And from that, it affects the whole, well, cascade of events. This second litter syndrome is not on its own, you could say. If a sow experienced a second litter syndrome, chances are that also later it will be not a good performing sow. And you can see that here for farrowing rate. So sows that are a repeat breeder after first weaning are shown here. And the sows that were not a repeat breeder, so simply farrowed the first time after they were inseminated, are here. And what you can see is that also in the third and fourth parity, these sows will have a lower farrowing rate. So sows that do not become pregnant the first after the first insemination, after the weaning, will also have a lower farrowing rate in subsequent litters. We don't understand exactly how that works, actually. And the same is true for litter size. So sows that have a low second parity litter size compared to high will also have a lower performance in parity 3 to 5. So also for litter size, you see that a second parity sow that does bad will have a bad performance after. So what we see is that a reduced performance in the second parity is related with the reduced performance in later parities, both for farrowing rate and for litter size, and that also results in earlier culling. So they're just less productive sows, and we simply don't understand exactly how that works. I've put up a few options here, and we simply don't know. It could mean that they are simply worse sows for fertility. It could also be that it's constantly the sows that have a very short estrus duration, and that's why it's more difficult to inseminate at the right time. That's why you get these effects. We simply don't know why it is the case. But the point is that this performance of the second litter sow is very important for its subsequent performance. So what can we do to stimulate that development of the second parity sow, to stimulate its performance? Because that will help us for the rest of its life for that sow. Well, we can do a lot of different things, and I would like to go through all of them. So first of all, we should try to stimulate the development of the gilt at farrowing. And the easy message is, if the gilts are too young and do not have enough reserves, body reserves, it will be very hard on them in their first lactation, because they will lose a lot of weight. They will have a low feed intake capacity and will lose a lot of weight. So we have to have mature sows at first farrowing. And I have kind of a proof of that. One example is that these are all gilts, and it's already a bit old data, but it's from our research farm in the Netherlands, from the university, where what I showed here is this should be, sorry, it says age in kilos, that's a bit strange. So it should be the weight, of course. So this is the weight at first weaning. Sows that are quite light at first weaning and quite heavy. And what I put in green is good and red is bad. So you can see that if they are very light at weaning, they have a lower reproductive performance and are also culled earlier. And you can see that this weaning age is very much related to the weight at insemination and also the weight at farrowing. So if you make the sows older, heavier at insemination, that will probably have a good response for the results in the second parity and later on. The second one is to stimulate the lactational feed intake. Of course, when sows do not lose weight, we have good performance, so a good feed intake is important. And now I don't know the English expression anymore on thin ice. No, I don't know. Yeah, thin ice, that's the right one. Because I'm coming from the Netherlands, where we do ice skating in the winter. And here you are in a part of the world where it's so hot that even in winter time, well, you are sweating probably all day. So who am I to talk to you about trying to improve the feed intake of sows during lactation? But anyway, I'm going to try. First of all, it's always difficult, this lactation feed intake, because we have sows that can be, that need a cool temperature to take in a lot of feed. And on the other hand, we have the piglets that need a very high temperature. So that's always already a complicating story. Actually, sows would do best if they would be in an environment of about 16 to 18 degrees. That would be optimal for their feed intake. Well, even in the Netherlands, we are not going to make that, but for us it's more a problem with the quality of the piglets then, that they survive. But anyway, and I realize it's not even easy advices for non-tropical conditions, let it be for tropical conditions, but what is essential parts about trying to stimulate lactational feed intake is, first of all, to have a limited feed intake during pregnancy. So at the end of pregnancy, the gilts should not be too fat, because then they will have a reduced feed intake during early lactation. Well, that should be possible, I think. The second one is adjust the feeding pattern. Use step-up patterns, so slowly increasing the feed intake in the first weeks of lactation. Look at the frequency of feeding, probably feed more times during the day, not only once or twice, but 3 or 4 times to make the feed intake higher. And, well, I said here, adjust the timing to the temperature. That's easy in countries where there is a big difference in the temperature between day and night. Of course, that's much more difficult when the temperatures are not so varying. Ensure sufficient water intake. Sows will only eat when they can also drink a lot. So the water needs to be fresh and readily available. So there needs to be a good output of the water nipples. Control the furrowing room temperature. Well, that's the big issue here, of course, where it's impossible to keep the temperature below 20 degrees. And well, you have to live with that. But you can do some things in high temperature, like, of course, having a good ventilation. Try some skin cooling of the sow, or even floor cooling, which is probably a very expensive way of trying to lower the input of the temperature on the sow, but works quite well. And I do have an example of that last one from, two. I have two examples, I think. This is an experiment from Ceva in Brazil, also considered a tropical region, where they had a cooled floor compared to an uncooled floor. And what you can see is, first of all, that the temperature of the sow in the afternoon was reduced by half a degree centigrade. So it really affected the temperature of the sow. And it also affected the feed intake and the body weight loss, and as a consequence also affected the weaning to estrus interval. And you can see there is a much higher output also of milk. Milk production went up from 7.5 to 9.6 kilos, which also affected piglet weaning weight. So in this case, the cooling of the floor had a profound influence on the production of the sow, which was good both for the welfare of the piglets, but also for sow reproductive performance. Another one is the lactational feed composition. If you can't stimulate the feed intake, can we change the composition of the feed in such a way that we, can either increase the energy intake, or that we can stimulate reproductive performance? And I also have some examples of that. First of all, the impact of dietary fat. And it would make sense. Fat has a higher energy content than other ingredients. So if you can increase the fat content of the diet, you can increase the level of energy intake of the sows. And that actually works quite well. What you can see here, and that's already quite old data, but still valid. And let's look at the animals that are kept at 32 degrees Celsius. You can see if you give animals a fat-rich diet, you can give them as a ad libitum intake, they will take in much more energy from the fat-rich diet than from the starch-rich diet. But actually what you also see is that weight losses don't differ that much. So how is that possible? We do get in more energy, but weight loss is not affected. And that's actually because when you put sows on a high-fat diet, what they will do is put this fat into the milk. And you can see that here. So if you have a high-fat diet, and this is the fat content of the diet, you can see an increase in the percentage of fat in the colostrum. Well, that's only a short period, but also a fat increase in the milk. And actually, in these experiments, what they found, 17 experiments, the control animals had 7.2% fat, and the fat-rich animals had 8.7% fat. So 1.5% fat. So this extra fat that you put into the diet goes into the milk. It doesn't help the sows that much. So high-fat diets stimulate milk fat output and result in fatter piglets at weaning. Might also be a benefit. High-fat diets result in increased fat mobilization in the sow, so it doesn't really help the weight loss of the sows. And it also means that you should have substantial increases in the energy intake to have a benefit for the sow from these high-fat diets. It might work, but it needs to give a big stimulus to the feed intake. Having said that, there is one relatively recent paper from Smith et al. From Australia, where they tried this again. They gave diets with an energy concentration varying from 13 megajoules digestible energy per kilo, from 13 to 15.3. And when you follow the lines, you can see that indeed the daily energy intake was much better, and they did see a much improved energy balance from a loss of 20 kilos to a loss of 10 kilos. And finally, they also found an influence on the weaning to estrus interval and the percentage of sows mated within 7 days. So in this Australian research, this increased energy intake definitely positively affected the body weight of the sows during lactation. But this is not first litter sows. No, this is not first litter sows, but it must also work for first litter sows. Okay, so this energy part is that, yes, it works. If you get enough extra feed into the sow, then these fat-rich diets can help to, for the energy balance of the sow and thereby for the reproduction. Another way of going with the feed composition is looking at insulin-stimulating diets. And that's on my next graph. When we talk about energy balance, it affects all kinds of nutritional hormones and intermediates, which affect the hypothalamus, pituitary, and also the ovaries, and that's why we get these responses in reproduction. Many of these responses are related with insulin, glucose, and IGF-1 as a group of components that are related with sugar absorption and, well, can't find the right words now, but anyway, that's one system, you could say. So what if we can stimulate, if we could stimulate insulin, glucose, IGF-1, could we then influence reproduction without even maybe influencing the energy balance? Well, I would like to show you, I guess, one example from this, from Australia. Not a very big experiment, but what they did was they used either a control treatment, a treatment where they substituted 1 kilo of the diet for a fat-rich diet, or 1 kilo of the lactation diet for a sugar-rich diet, and last, but I probably won't talk about that one. Oh well, I will show it also. That where they gave, they weaned the sows, but they gave the sows 19 days a treatment of altrenogest. And we haven't discussed that yet, but when you give altrenogest, you stop the cycle. You limit follicle growth, you stop the cycle. So what you do when you give altrenogest is that you kind of give the sow the opportunity to restore its energy balance simply by extending the time to next estrus. So you give the altrenogest, and during altrenogest the sows will not show estrus, but they will show estrus after this treatment. So what happened with the results? Well, first of all, what you see with these different diets, that you clearly get an effect on the plasma insulin response. So sows that you give a sugar-rich diet have very high levels of insulin, and sows that you give a fat-rich diet have low levels of insulin. Exactly what you would expect. What did that do with reproduction? Control animals had a very low reproductive performance. Total born, 10.7. Animals on the fat-rich diets were much higher, but not significantly so, but still a bit higher. Animals on the sugar-rich diet had a much higher, a significantly higher litter size. So this is actually what you would expect, but it's a big influence if the insulin-stimulating diets also influenced IGF-1 levels and thereby stimulated follicle development. It kind of follows in a logical pattern that you could assume, although the effects are very big here. Interestingly, also the altrenogest treatment, so where you have the control treatment, but make them restore after weaning for a 9-day period, you can see that you get quite a high litter size. So also making them restore a period after weaning helps for the subsequent reproductive performance. So the conclusions on this part is that excessive weight loss reduces the subsequent litter size and farrowing rate and decreases litter uniformity. So that's a problem. How can we try to avoid this excessive weight loss? By all kinds of management measures. And when you talk about the measures related to feed, then an increased fat content could work, but you need quite a high increase in feed intake to be of a positive effect. And insulin-stimulating diets may also have a positive effect for subsequent performance. So, relax for one moment. We're all there again. Yeah, so that was all about the lactation feed, and which is a very important part of trying to stimulate the postpartum, reproductive performance of sows again. There are some other things we can do. For example, reduce the suckling intensity in late lactation. I already told you that these consequences for follicle development are very much related to the energy balance, but besides that also by the suckling intensity of the piglets. That makes the lower LH pulsatility and thereby the worse follicle development. So if we have fewer piglets or we make them suckle less, could that stimulate the development of the follicles and thereby the reproductive performance? Well, first of all, you can think about piglet numbers in general. So not put with this first litter sow, simply put fewer piglets. Actually, when I say that in the Netherlands, they laugh at you because they don't have space for these piglets. If you take them away from the first litter sow, you have to bring them somewhere else. Well, if all the sows have large numbers of piglets, you don't have any place for those piglets. But if you have lower litter sizes, you could try to bring some of those piglets from the first litter sow to the older sows. Lactation length, I put a question mark there. Not much known about effects of lactation length, and it all seems in a quite big range. There doesn't seem to be a big influence of lactation length on subsequent performance. In research, people have used two strategies, and I would like to tell you something about those strategies. One of them is split weaning, and split weaning means that in the last few days, 5, 6, 3 days of lactation, you take away some of the largest piglets. Here it says remove 6 largest piglets 4 days before weaning, but there are some variations in the way people have dealt with that. If you take away those piglets, it will reduce the suckling stimulation. That could already help with the starting up follicle development, but also it should normally increase the energy balance of the sow if they don't have to produce so much milk. And the other one is intermittent suckling, and in intermittent suckling means that you take away the whole litter for a part of the day. That's very labor intensive, of course, but we've done it in research, and I would like to show you how that works. So here you see how it works. You can do it in 2 ways, actually. First, what people did was just simply put a board in the crate, in the pen with the sow. So have the piglets on this side for half of the day and the sows on that side. And the other way would be to take the sow away from the piglets for 2 times a day. This one, of course, is very labor intensive, but we found out that if you only do this, it doesn't work enough. So apparently, because the sows still hear and maybe smell the piglets, the startup of follicle development is not so good. So if you want to make it work, you have to take away the sow so far that you can't hear or see the piglets. Well, if you do that stimulation procedure, what you will see happening, and what you see here, is the interval from farrowing to onset of estrus. So what we did was, during lactation, try to get an estrus. So at 19 days of after farrowing, we started with this procedure of taking away the sow for 10 hours a day. And what you could see is that many sows simply started up the cycle within 5 or 6 days. A normal weaning to estrus interval. These was with animals that we started at 19 days. And other animals we started, this is also 19 days, but we did it for 14 days. We had a group where we started at 26 days for 7 days. That's this group. Also, a very rapid startup of the cycle in the same way as our control animals that were weaned at 26 days. So the control animals, in the end, 95% was in estrus after about 5 days. It was a little bit later, a little bit lower in the animals where we did this intermittent suckling, but you can see it's quite effective way of stimulating, if you go on with it, to stimulate even estrus and ovulation. If you want to do it to improve the follicle development, then you could only do it for 3 days instead of 7 days, for example. So it's a way of starting up to, it shows that the suckling intensity of the piglets, of course, indeed is important for the reduction of follicle development during lactation. What we did in our experiment is those sows that came in estrus during lactation, we also inseminated those sows. So what you see here is that we had sows that showed lactational estrus, and we inseminated them, and you can see that we had an 80% furring rate and a very high litter size also, 15.2. So actually, you can inseminate sows during lactation, and the reproductive results will be quite the same as when you inseminate after weaning. So the conclusion on this intermittent suckling part is that if you take away the sows from the piglets for 10 to 12 hours a day, it will, of course, reduce the suckling stimuli. It will result in an increase in follicle development, and you can even get lactational ovulation. And I say here part of the sows, because depending on the circumstances, of course, we have found that in some cases only 30% of the sows will ovulate. In other cases it will be 95%, so quite some variation. And actually I started this presentation as a second parity sow. When we did this only in second parity sows, they respond less to this intermittent suckling strategy. So it's more difficult to get first parity sows to ovulate in this system than older sows. But it might be a way to increase the follicle development in those animals. And as a last point, when you continue with the procedure during pregnancy, so we weaned those sows after 1 week, but if you continue the lactation and pregnancy, you can't do that too long. I mean, a sow is not a cow. In a cow it goes quite well together, but in the sows it means you have to stop this lactation about 7 days, it doesn't say here, but about 7 days after insemination to get still good results. Otherwise you get a lot of embryo mortality. Yes, I want to say something. I'm just thinking about the time. How much time do I have? 10 minutes. I would like to say something about this because maybe it is an option for your countries, split weaning. And there's not a whole lot known about it, but as I said before, it's the procedure where in the last part of lactation you take off a few of the heaviest piglets. And as I said, not much good practical data are available from that. But here you see an experiment from Zach in Canada, where they did it, and they looked very closely at the reproductive hormones, reproductive hormones, where they did split weaning in the last 3 days of lactation compared to conventional weaning at 21 days. We consider that quite early, actually. And what you see when you do this split weaning, so they took off the sows, the piglets, 3 to 5 days before the end of lactation, you can see that the weaning to estrus interval was reduced. Well, this is in hours, so it's less than 5 hours less than 5 days compared to, 6 days? They saw some changes in pulses of LH, which were associated with that reduced interval, and also the follicle numbers at the ovaries were higher when you did the split weaning group. So indeed proving that when you take away some of the piglets, it will improve the follicle development and possibly also the reproductive performance after weaning. But as I said, there are not much practical data on that. Okay, so the conclusion on the split weaning part is that when you remove this majority of the litters, you reduce the suckling stimuli, you stimulate follicle development, and you get a reduced weaning to estrus interval. And even if you would continue with lactation, you would probably induce the lactational estrus or ovulation. And maybe it's a good strategy to try in these hot climates to reduce the impact of lactation on the sows, especially the first litter sows. So that was actually everything that I would like to tell you about how lactation can impact subsequent fertility and how you can deal with that. Well, after lactation, of course, you have the weaning to insemination interval, which is very short normally, 5 to 6 days. So you can't do too much in that interval to further stimulate the reproductive performance. However, the general recommendations, of course, are that also there you have to try to give them a high feed intake. Also, because of this insulin and IGF-1 effect that's important during lactation. Also, after lactation, insulin and IGF are important to stimulate follicle development. So that's also why there the high feed intake is important. And also there, possibly these insulin-stimulating diets may be important, although we have done some research on that, and it simply seems that this interval is too short to make really a difference there. Obviously, also good bore contact is important, already to see the estrus, but also the bore stimuli, the olfactory stimuli, the smell of the bore is also important because it can even increase the LH pulsatility. So there's a direct effect of bore contact on the development of the follicles, you could say, through the LH effect. So in this short weaning to estrus interval, these are important aspects. You can also think about exogenous hormones at weaning if things don't work out. I have one example of that. And another possibility might be to postpone the first insemination after weaning. So if animals really come out of lactation very badly, then you could either use skip a heat, do not inseminate at first estrus, but 3 weeks later. I think I have an example of that later, of what it brings in terms of numbers of piglets, or alternatives, and I come back to that also, if I have enough time. This is one example on the use of gonadotrophins at weaning. So if sows come out of their first parity badly, you can try to give them gonadotrophins. Gonadotrophins, it's a strange abbreviation actually. Gonadotrophins, PG, at weaning. And as you can see here, and this is just one example because it was quite a recent one. Most of this research is done already in the 70s and 80s, so I tried to find a more recent one from Patterson in Canada. And where you can see is actually what it is used for, so that you can get a reduced weaning to estrus interval when you give the gonadotrophins. And actually, in this case, you can say they didn't really have a problem, because it was 4.4 days and they make it 4.0 days. That's not a huge impact. But if you have a much worse control group, as you could say, maybe a farm where you work or that you have, then you can have quite a big impact of gonadotrophins at weaning. And sometimes you also find effects on litter size, but usually that is not the case. Usually it's an effect only on weaning to estrus interval. Well, skip a heat. I already said, I mean, you could consider skipping the first heat after weaning of your first litter sows. And this is examples of what kind of effect that can have on your litter size, and it can be quite extensive. So from 10.4 to 12.9, 2.5 piglets even, 11 to 12.3, 1.3, 10.7 to 13.2. You see incredible effects on both litter size and farrowing rate. So with a very bad performance of first litter sows after weaning, you could consider to skip a heat, although it will cost you 21 days, of course. So you have to do the economics to see if it's worthwhile, but it might be a strategy. And that it works, you can also see in large data sets like this one, where the red line is the animals that were pregnant from their first insemination, and the black one is the ones that were pregnant from the second insemination, the repeat breeders. So this was not a case of skip a heat, but simply the ones that did not come in or did not get pregnant from their first insemination, but you see the same effects on litter size. So the repeat breeders did much better than the ones that got pregnant from their first insemination. So again, showing the consequences of this lactation on the subsequent performance. Yeah, so if you do skip a heat, I already told you, if you do skip a heat, you have 21 open days extra. That's a lot of, well, economic losses, you could say. Is it worthwhile? Another option could be to use altrenogest after weaning. Altrenogest is a progesterone analog, a progestogen, and you could say, it's a bit strange phrasing, delays pre-ovulatory follicle development. It means that as long as you give altrenogest, the follicles do not grow out. It's the same as you use it in gilts to synchronize the cycle, so they don't grow out. The moment you stop with altrenogest, then the follicles start growing again, and after 5 days you expect an ovulation. So then you don't need 21 days, but you could say, okay, I do it for 5 days, or I do it for 10 days. Would that be enough to restore the follicles and have a good reproduction afterwards? Well, we've done some research on that, and the reason, well, people have started doing research on that already in 1982 were the first experiments in France, for example, Martina Bottet. And you could see, only look at the red, very variable results. So people have tried it for several days and found very variable results. So we've done a few experiments, and I skipped that one, I think. Maybe not. It's always difficult when you run out of time. The message actually is that although I think altrenogest could be a good option after weaning, we don't have the right strategy yet. And I can show you here why you can also have wrong strategies. Here we gave this altrenogest either for 4 days, so we had control animals, and this experiment actually was done in Argentina. Control animals that were given the product altrenogest for 4 days, for 8 days, or for 15 days. And when you only look at farrowing rate, because the consequences for litter, well, farrowing rate first, you see there is not an improvement when you give it for 4 days, and it's much worse when you give it for 8 days, and it's very much improved when you give it for 15 days. For litter size, it's only improved when you give it for 15 days. So from this graph, you could say, okay, altrenogest could work, but you need to give it for 15 days to get a positive effect. And that's about all we know at the moment. The only thing we know, well, extra, is why does it go wrong here? And we have kind of an explanation why it goes wrong at this stage. And that's some reproductive physiology again. Because what we saw is that indeed the follicle development restores when you give this altrenogest treatment. But we think, and that's the number 2, we think that when you give it only for 8 days, the lactational follicles will go into atresia. So what you do is, when you start the altrenogest, follicles start growing, but it's actually the old follicles from the lactation. When you stop at 8 days, those old follicles, you make them ovulate. But it's old follicles, it's not good quality follicles. So you need to give it for more than 8 days, so these old follicles are gone, they are simply go into atresia, and then new follicles start to develop. So we think you need to give it for more than 8 days to make sure that these old follicles are gone and the new follicles will develop and give a better litter size. And that's about all we know at the moment of, well, the possibilities of giving altrenogest after weaning to postpone that first insemination. So the last part, what could be important is, okay, we had this lactation, we can't do anything about it anymore. This wean to estrus interval is very short. Well, we could increase it. Can we do something in the next pregnancy? Can we stimulate the recovery of the sows during the second pregnancy? And does that help for reproductive performance? I have one example of that. Will take not too much time, I guess, because I think it is important. What we did is we had our control animals in the second pregnancy. We gave either 30% extra feed, and now I'm thinking, so the control animals got 2.5 kilos of a certain feed. The animals got 30% extra, or they got 30% extra protein. And the message here, you can see it, if you give them extra feed in the first month of lactation, or of pregnancy, you can see a big increase in the number of born piglets. So definitely, when you increase the feed intake in the second pregnancy, you get a very much higher litter size in this experiment. However, although not significant, we did see a reduction in the pregnancy rate. So there seems to be a trade-off between pregnancy rate and litter size. And actually what we think is happening, you can see it on this graph. If you look at the piglets being born, here you see the distribution. So the animals in the control treatment, we had quite a lot of litters with only 5 to 9 piglets and 11 to 13 piglets. Whereas the animals in the plus feed treatment hardly had any piglets in this area. So our suggestion is that when you give this high feed level, and there are sows with only a few embryos at that stage, that sows with only a few embryos will lose their litter if you give them a high feed intake. And that's why you get a lower farrowing rate, but a higher litter size in the end. And the question, of course, is what you want as a farmer. Do you want a higher farrowing rate, or do you want a bigger litter size? What people told me in the Netherlands, some people said, okay, we don't mind this lower farrowing rate if we have a bigger litter size. I'm not sure that's true everywhere. But anyway, it shows that with extra feed in the first month of pregnancy, you can restore the body development of the sows, logically, but you can also interfere with the reproductive processes, embryo mortality, embryo survival. To sum up again, that what I hope I did was showing how important this lactation period is for the subsequent performance of the sows. And it's only such a part of all the things that are important, but at least I hope you have that message. So that leaves me with thanking you for your attention.